everyone. For this video, we're going to talk about areas of sectors and areas of segments of a circle. This is just a continuation of the previous topic that we discussed. So of course, let us have our learning target that hopefully everybody can achieve after watching this video. I can determine the area of the shaded region, or else to be specific, hopefully you can determine the area of the sectors or else the area of the segments of the given circle. So here's the guide questions, guys, that hopefully you can be able to answer or elaborate after watching this video. So first, how do we define a sector of a circle or else a segment of a circle? Next, we have how do we determine the area of a sector of a circle or else the area of a segment of a circle. Okay? So first, let us have our short recall or recap of the previous terms or formulas or descriptions that we tackled in our previous lesson. So here, I'd like you to tell whether the given statement is true or false. So the distance around a circle is called a perimeter. The answer is false. Next, if the radius of a circle is 15 centimeters, its circumference is 30 pi centimeters. It's true. Next, the circumference of a circle is the limit of the perimeters of any inscribed regular polygon. It's true as well. Okay, so next statement, if the circumference of a circle is 10 centimeters, then its radius is 5 centimeters. Our answer is false. Next, for any circle of radius r, the ratio c divided by 2r is denoted by pi. This is true. Next, 1/2 the circumference of a circle is equal to the length of the radius times r. This is true as well. Okay, so this time I'd like you to complete the given statement to make it true. Okay, first statement, the area of a circle with radius r is blank. So in short, what is the formula to find the area of a circle? Pi r squared. Next, the area of a sector whose measure of the arc is A is, so this time, what is the formula to find the area of a sector? So A divided by 360 degrees times pi r squared. Next, a blank of a circle is a region formed by an arc and the chord having the same endpoints as the arc. So the answer is a segment. Next, to find the area of a segment, subtract the area of the blank from the area of the blank. Okay, so in this last question, we need two answers. So for our first blank, what do you think is our answer? Area of triangle, and then subtract it from the area of what? So sector. Okay, so now let us have our short sheet work and let us check if we can now apply our concepts in finding the area of our sectors or segments of the given circle. So take note, guys, in this activity you might be finding for the area of either our shaded part or unshaded part or else region. So take a look with the given instruction. So here in our first example, I'd like you to help me find the area of the segment of the given circle, and therefore this is what we're going to look for, the area of this yellow shaded region. Okay, so let's start with what is the formula in finding the area of the segment of a circle. So I do hope you can still remember. So area of a segment is equal to area of a sector deducted by or subtracted by area of a triangle. Okay, so let's do this one by one before we move on to the substitutions of all the areas that we need. So let's start with the area of a sector. Okay, so let's substitute in our formula. So here, so as given, our measure of a degree measure of the intercepted arc is 90 degrees. Of course, we are supposed to copy 360 degrees times pi, and our r is 5 centimeters and squared. Okay, so we need to simplify this. 90 degrees divided by 360 degrees, because we all know both are divisible by 90. So 90 divided by 90, it's 1. 360 divided by 90, it's 4. Then multiplied it with pi. Just simply copy pi for a while. Then 5 centimeters squared, so that means this is 5 centimeters times 5 centimeters, so 25 centimeters squared. Okay, moving on, let us multiply 25 centimeters squared with 1/4 and multiply with pi. So with that, we can have 25 over 4 pi centimeters squared. Okay, so now I'd like you to multiply 25 divided by 4 with the approximate value of our pi that we are using, which is 3.1416, and copy the unit of measurement, of course. So now, using your calculators with you, you divide 25 by 4 and multiply with 3.1416, and therefore, we will be able to get area of the sector is approximately equal to 19.635. Of course, since we're talking about area, so unit of measurement must be expressed in square unit. Okay, so now let us take note of this first. So our area of a sector is 19.635. Okay, next is, let's proceed with finding the area of our triangle. So this one, triangle TQP. Okay, so of course, our formula is area of triangle is equal to 1/2 base times height. So now, let us substitute, guys. So we have equals 1/2 and our base. So take note, guys, as you can see, our intercepted arc measures 90 degrees. Therefore, the central angle corresponding to this intercepted arc is also 90 degrees or right angle. So this one. So therefore, we do have a right triangle here. And we all know the side, the opposite to our right angle is considered our, this one, the side QP. This is our hypotenuse. And with that, we can conclude that our base and height would be the segment TQ and TP. Okay, so if you're going to observe, segment TQ and TP are both radii. Therefore, they are considered the same in measure. So, with that, we can say that our base is 5 centimeters and our height is 5 centimeters as well. Now, let us simplify further. So, 5 centimeters times 5 centimeters, we would have 25 centimeters squared. But of course, we're not yet done. So, area of triangle, what is 1/2 of 25 centimeters squared? And with that, we will have 12.5 square centimeters. Okay, so I'd like to take note this one again. So we have this. Okay, so now we are going to proceed with substitution of all the areas that we've got. For area of the sector, we do have approximately equal to 19.635 centimeters squared minus area of the triangle that we've got is 12.5 centimeters squared. And therefore, the area of the segment now is approximately equal to 7.14 centimeters squared. So we are going to follow our basic rule wherein our final answer must be round off to nearest hundredths. So now, our final answer is 7.14 square centimeters. Okay, so for our next example, we are going to find again the area of the segment of the given circle. So of course, we are going to stick with our formula. Area of the segment equals area of the sector deducted by area of the triangle. So let us get the areas of our sector and triangle first. So we have here our formula for area of a sector. So substitute the given data. So for our measure of the intercepted arc is 60 degrees and then our radius is 12 inches. So here in our illustration. So simplifying, we all know 60 and 360 degrees are both divisible by 60. To simplify it, 60 divided by 61, 360 divided by 60, it's 6. And 12 inches times 12 inches, we do have 144 inches squared all in all. Now, let us multiply 1 over 6 with pi and 144 inches squared. But instead of multiplying, we can see that we do have this value 6 and 144, wherein we can simplify this already because 144 and 6 are both divisible by 6. And with that, we can cancel this out. So 6 divided by 6, so this would be 1. And 144 divided by 6, so this would be 24. And with that, we will have, if we're going to multiply it, 1 divided by 1, it's 1. So there's no need for us to write it anymore. So pi times 24 inches squared, so we will have 24 pi inches squared. But of course, this is not yet our final answer because we are advised to multiply it with the approximate value of pi that we are using, which is 3.1416. And with that, multiplying this, we would have area of our sector is equal to or approximately equal to 75.3984 inches squared. So for now, this is our answer for area of our sector. Okay, so next is, let's find out the area of our triangle. So what is our formula again? So 1/2 base times height. And now, so of course, we're going to substitute the value of our base and our height. So here, as you can see, we don't have a right triangle here. And with that, it is somehow tricky on our part to find our base and height here. So what are we going to do is, let us draw a bisector perpendicular to the one of the sides of our triangle. So I'm gonna start it here. Since it's given 60 degrees, so if I'm going to draw a bisector here, therefore we can say that instead of having this 60 degrees, since it's divided into 2, we would have 30 degrees here and 30 degrees here already. And since we have drawn a segment perpendicular to the segment of the given triangle, therefore this indicates 90-degree angle. And with that, we can say that the opposite side to this is what we called our hypotenuse. Now, if this is our hypotenuse, therefore we can say that this segment that we've drawn as bisector is considered our height of the triangle, and of course this would be our base. But let's focus on this portion only. So as you can see, since this is a 30-degree angle, 90-degree angle, and therefore we can say that this portion, this angle measures 60 degrees. And hopefully you can still remember our concept on 30-degree, 60-degree, 90-degree triangle theorem. Okay, we all know, using our 30, 60, 90 triangle theorem, the side opposite to our 90-degree triangle is represented by an expression 2x, and the side opposite to our 30-degree angle is represented by 1, is represented by x, and the side opposite to our 60-degree angle is represented by x square root of 3. But now, we don't know yet what is x. But we do have here the clue. Our hypotenuse is considered our radius as well. And so, it's given that our radius here at the other side is 12 inches. Therefore, we can say that 2x is equal to 12. And with this, we can get x is equal to 6. And with that, we can say that the base here, the half of the base, is equal to 6. And then our height, this one, the perpendicular bisector that we've drawn, is equivalent to 6 square root of 3. Okay, and with that, we do have the idea already that our height would be 6 square root of 3, and our base should be, is it 6 or 12? So it should be 12, because 6 is only half of the given triangle. So half of the given base only. So that means we are supposed to substitute our base is 12 and our height is 6 square root of 3. Next is, of course, we need to get half of 12, so that's 6. So multiply 6 with 6 square root of 3, we would have 36 square root of 3. And of course, we need to simplify it further. We need to convert it into decimal, and that would be 62.35 inches squared. And for now, we got this area of our triangle is 62.35 inches squared. So since we do have the area of our sector and area of our triangle already, so we can now substitute in our formula to find the area of the segment. And of course, subtracting these two areas, we can now have area of the segment is equal to 13.04 inches squared. And this is our final answer for this problem. And we are done. Okay, so let us have our additional practice exercise, and hopefully you can master already the topics on areas of sectors and segments of the given circle. So here are the following illustrations that you will be able to encounter in our activity. So what are you supposed to do? You're going to find out the area of either the shaded part or unshaded part of the given illustration. So take a look with the direction given. Okay, so here we're going to find out the area of the shaded region. So of course, I'm gonna stick with the formula of area of a sector. But as you can see, we do have our task is we're going to find out the area of the shaded region, and we do have two shaded regions here. But luckily, we do have this hint. The intercepted arcs of the two unshaded regions are given, which are 140 and 120. What I'm going to do is I'm gonna add 140 and 120, so it's 260. So I will deduct it from the total number or total degree measure of a circle, which is 360. So I would have 360 deducted by 260. That means 100 degrees. So therefore, we can say that the sum of the degree measures of the intercepted arcs of these two remaining shaded regions are or is equivalent to 100 degrees. And with that, this is what I'm going to use in the formula for area of sector. And so I would have 100 degrees divided by 360 degrees times pi, and of course our radius would be 10 inches squared. Okay, so now I'm gonna simplify first 100 and 360. So both are divisible by what number? So both are divisible by 20. So 100 divided by 20, that is 5. 360 divided by 20, that is 18. And I'm gonna multiply it with pi. And what is 10 inches squared? So 10 inches times 10 inches, we would have 100 inches. Okay, and of course, I'm gonna put squared, by the way. So now, 5 over 18 multiplied with pi and 100 inches squared. Therefore, I would have, actually you can simplify this. So 118, both divisible by 2. So you would have here, you can cancel this out. So this would be 50, this would be 9. Okay, and with that, you can continue with 5 times 50, you would have 250. And then 9 times, of course, it's a whole number 50, its denominator is 1, so 9 times 1 is 9. And of course, copy the pi and then inches squared. So we're not yet final. Of course, we need to multiply the quotient of 250 and 9 with the approximate value of pi that we are using, which is 3.1416. And so we will be able to get, so since you are using your calculators with you, I'd like you to do this directly. So 250 divided by 9 equals 27.7777, repeating decimal, times 3.1416. And that means we would have 87. So area of our sector is equal to 87 point, and since this is our final answer, we are going to round off to nearest hundreds, and therefore our final answer, area of the sector, or shall I say, to be specific, area of the shaded regions, the two shaded regions, is equal to 87.27. Oh, I forgot something, so there should be unit of measurement, so inches squared, by the way. So area of a sector is approximately equal to 87.27 inches squared. Okay, so moving on. So for our next example, this time we're going to do this vice versa. We are going to find the area of the unshaded region, but this would be quick, guys. So first, let us find the area of the given circle. So as you can see, we do have this four-sided polygon. It's given the side is 12 inches. So therefore, since it's actually a square, therefore all the sides are equal, so 12 inches. And as you can see, we do have here 4 shaded circles inside our given square. So we need to find the area of our circle and we need to find the area of our square. So let's start first with the area of our circle. Now, so hopefully you can still remember. So here, so we have pi, so 3.1416. So I'm gonna substitute all already. And radius would be, what do you think will be our radius? Analyzing the given data, if a square, as you can see here, we do have 2 shaded circles inside a given square. Now, as you can see, looking at the side of this given square, so if we're going to draw a line here, So parallel to the side of the given square, we can say that if the side of the square is 12 inches, therefore, this one, the sum of the diameters of our two given circles would be 12 as well. But since we need to find out first the diameter of one circle, so if it's 12, diameters of the two circles, it's 12. Therefore, so for each, they would have 6 inches for its diameter. But since we need the radius, so if the diameter is 6, therefore, our radius that we are supposed to substitute in the formula would be half of 6 is 3. So 3 inches. And then of course, let's put the square. Okay, so now let us multiply or simplify first. What is 3 inches times 3 inches? So we do have 9 inches squared. And lastly, let us multiply it with the approximate value of our pi, and that is, we would have area of a circle is approximately, so approximately equal to 28.2744. Okay, so actually this is the measure of or the area of one circle only, one shaded circle. But since we do have 4 shaded circles here, so that means we are supposed to multiply area of the 4 shaded circles, 4 circles. So we can have 28.2744 times 4, and with that we would have 113.10 inches squared. Okay, but we are not yet done. This is just the area of the 4 shaded circles. Okay, next is we are going to find out the area of the square itself. So of course, so this is very quick. So side is 12, so 12 inches. Simply square it, and that means we would have area of square is equal to 144 inches squared, and we are done with the area of our square. And lastly, last thing we should do is what? So we are going to subtract. So area of, to find the area of unshaded region. So it's quite long. So unshaded region is equal to area of our square minus area of our circle. Okay, so now our area of square is 144 what? Inches squared minus 113.10 inches squared. So that means the area of unshaded region is approximately equal to what? So 144 minus 113.10 equals 30.9 inches squared. And now this is our final answer for the area of unshaded region. Okay, so next is I'd like you to solve on your own. Find the area of the shaded regions of the following figures. So we have here. So if you are not yet done solving for this, you may pause the video for a while, and then if you want to check, this is our answer for this. So 16.76 centimeters squared. Next figure, You may pause again the video, and if you're done, you may check your answer, and our answer for this is 100.53 square centimeters. Okay, last. Okay, so if you are done with your answer again, you may now proceed with checking your answer, and that is 60.73 square inches. So that's it for this video. Thank you so much for watching.